Okay, so this is where we left off. Is last time we took notes, we took a look at how to use a tree diagram to answer certain probabilities. What I want to do with this question is you don't have to do a tree diagram. There is another way to approach this question that I'm going to show you. I will say, for me personally, I find the tree more intuitive, but you certainly don't have to do it my way. So let's say that you had started this problem fresh and you did everything in green. What you could do is you can also use a two-way table. So I'm going to do this in a different color so that we know. Or we can use a two-way table. Okay, here's the deal with a two-way table. Of course, you're making your two ways. We have two events in this case. The person is a drug user or is not a drug user. Test positive or does not test positive. Now, you can do this using probabilities. You can use this table to use people. So what I'm going to do is I'm just going to suppose that I have 1,000 people. And then I'm going to use the probabilities that I have above. So the first thing that I know is I know that 4% of people are drug users. So if I take that probability of D, which is 0.04, and I multiply it by that 1,000 people, that tells me that 40 people in my table are drug users. So that 40 goes here, which means then there are 960 that are not drug users. Then I'm going to use those conditional probabilities that I have. So if I use this conditional probability, so I have the probability of T given D complement. So that is going to be the probability of T and D complement over the probability of D complement. Okay, well the T given D complement I have, that's that 0.05. The T and D complement I do not have. So T and D complement, T would be right here. I don't have that. But the non-drug users I know is 960. So then if I cross multiply, I get that T and D complement to be 48. Now, that's not a probability, right? It doesn't make sense to say a probability is 48. But what it tells us is that 48 goes in the table. So this right here, 48. That's all we need. We can fill out the rest from here. If I know this column is 960, if I subtract 48, that tells me that I have 912 here. I guess I'm not quite done yet. So now I'm going to have to take a look at that last probability that I haven't used yet, which is this one. So the probability of T complement given D, so that's going to be T complement and D over D. So I get 0.1 is equal to the probability of T complement and D. And then we know in our table there are 40 drug users, which means in the T complement and D, there's 4 people here. If I were to multiply these two, T complement and D would give me 4 then. Again, it's not a probability, it's just the number that falls into that box. So then 36 falls here. So this is a different way to not use a tree if you don't want to. So then if it asks you, like we got asked, what is the probability of testing positive? Well, the probability of testing positive on our table, it's these people divided by our total. So we would do the 36 people and the 48 people divided by the 1,000 people. And it would get us that 0.084. Similar idea down here. You are never required to use one over another. So I would suggest to you, you pick the one that you like and that's what you do every time. There's not one that's easier than another. So either two-way table or a tree, like I said, would choose one and just be consistent with that. questions? Okay, bless you. A few more things to talk about. Oh, there's a... Okay, I think the next question on the next page. Is this where you have a question? Okay, multiplication rule for independent events. I don't even really want to call this a rule because it's not. We've already taken a look at the probability of A given B, and we said this is the probability of A and B over B, and that's on your formula sheet. And then what we said is that we can solve this for A and B. And if we do, we get the probability of A given B times the probability of B. Right, this is called the general multiplication rule. When I said don't memorize that, it just comes from the conditional rule. Okay, now, if our events are independent, and only if they are independent, then we know that the probability of A given B is just the probability of A. And the rest of the rule stays the same. So this is a very powerful idea, but only if the events are independent. And that's all it is we're changing the conditional to just the probability of A, and that is because the events are independent. Questions? Okay, let's do 2 more problems and then we're done with notes. The first trimester screen is a non-invasive test given during the first trimester of pregnancy to determine if there are specific chromosomal abnormalities in the fetus. According to a study published in the New England Journal of Medicine in November 2005, approximately 5% of normal pregnancies will receive a false positive result. Assume that the women's test results are independent. Among 100 women with normal pregnancies, what is the probability there will be at least one false positive? Okay, so here's what we have going on. First of all, we have normal pregnancies. So I'm going to let N be a normal pregnancy. And then we have this positive result. So I'm going to let T be a positive result. And so then it says, according to a study, blah, 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 approximately 5% of normal pregnancies. So that is, given the pregnancy is normal, the probability of getting a false positive is 0.05. So I'm going to call that T actually a false positive. The notation isn't super important. Okay, so let's try to look at what it's asking us for. Among 100 women with normal pregnancies, which means we're using this probability, what is the probability that there is at least one false positive? So probability is of at least one false positive. Okay, so we need to find the probability of one false positive and 2 false positives all the way up to 100 false positives out of the 100 women. Right? At least one is 1 false positive, 2 all the way up to 100. You with me so far? Okay. I'm lazy. I don't want to calculate all 100 of those. So if we look at how many false positives are possible, it would be 0, 1, all the way up to 100. So that's what's possible. If I want 1 to 100, rather than doing that, I'm going to calculate the only case that I'm not interested in. This is the complement. So I'm going to calculate the only case I'm not interested in, which is that 0. So instead of doing 1 to 100, what I'm going to do is I'm going to find the probability of no false positives. And I'm going to subtract it from 1 because it's the complement. So if I find this case and I subtract from 1, I'm going to get all the rest of them. Okay, well, if a false positive is 0.05, Not a false positive then is 0.95, but it's 0.95 for the first woman and for the second woman and for the third woman for all 100 women. Now, what I would like to be very careful about is the only reason we can do this is because we are assuming that these test results are independent. You are never to assume independence. It was stated that the test results are independent. So that's the only reason we could do that. If we weren't told that they were independent, there's nothing we could do. So then this answer is about 0.994. So if we took 100 women with normal pregnancies, about 99% of the time, at least one of them is going to have a false positive. Okay, so what I'm trying to tell you is anytime that you see at least, what should go off in your head is calculate the complement. That'll be a lot easier. Okay, last question. On a recent day, the Arizona Daily Star forecast a 50% chance of rain in Oro Valley and a 50% chance of rain in Marana. What is the probability it will rain in both locations? So we are looking for probability that it rains in Oro Valley is 0.5. Probability that it rains in Marana is 0.5. What is the probability that it rains in Oro Valley and Marana? We can't do this. So what you don't want to do is take 0.5 and multiply by 0.5. Can't do that because we don't know if these two events are independent. So I'm going to say can't do because O and M may not be independent. Again, do not assume independence. I think there's one in the book you had to, but besides that, I will always tell you that events are independent.